So now we begin with the next topic in the second chapter, motion in a straight line, which is relative velocity. So see, we got very few questions here. I think somewhere close to 10 to 15 questions in JE mains. We'll definitely cover a lot of questions in NEET and, if possible, from other topics as well. So in this question, and if possible in every question, what I'll do is I'll try to make sure that the sign convention, which actually is something which is very confusing, especially when you attempt these questions for the first time, right? So we'll we'll see two ways of choosing the sign convention, but there are many ways to look at it. We'll stick on to these two in every possible problem. Okay. Now, when I say sign convention, what do I mean? What should be the sign of U, V, A, T? Oh, sorry, not T. U, V, A, S. Okay. So, how to choose these? How to choose the sign convention for these values? So, we'll choose two methods. One would be to consider all those quantities which are along the direction as positive and against the direction as negative. And two would be to choose coordinate axis to represent these values as vectors and then find out their respective sign conventions. Okay. So as usual, I would suggest you that you make detailed notes of one time, like just for one time, for the first problem alone. I would suggest you to make detailed notes of both these conventions and then work on the coming topics on your own, coming questions on your own, choosing either of these. And once you're done 10 to 15 questions, using both these sign conventions, I can assure you that things will become really clear to you and you'll be more confident in solving any question that is based on relative velocity. And it will definitely help you in solving questions which are also based on motion motion under gravity. Well, this question can actually be seen, as based on motion under gravity also. Okay. Anyway, coming to the question. So this question primarily is explaining three different cases. One in which an object is thrown vertically upwards. Two, which is thrown vertically downwards. And three, where it is dropped. And we've been asked to find out the relationship between time t1, t2 and time t of these three cases respectively. So we'll begin with case 1. So case 1, when the ball is projected vertically upwards, the sign convention what I've chosen here is choosing every measurement which is along the initial direction of motion as positive and against the initial direction of motion as negative. Now, since the initial direction of motion of this object is upwards, direction of initial velocity is upwards, therefore u is positive. Displacement, which is the final position minus the initial position, b minus a, which is below this initial position, is taken as negative. And acceleration due to gravity, since at every point of this, at every point of the path of this object, acceleration due to gravity will always pull this object towards the earth, right? Acceleration due to gravity will always pull the object towards the earth, therefore acceleration will also be taken as negative. Now, why negative? Because it is opposing the initial direction of motion, right? So to summarize this, we have u as positive, s as negative and a as minus g. So the third equation of motion, s is equal to ut plus half at square, is used here. Now what is s? S is negative, so we'll take it as minus h. What is u? It is positive, so that becomes plus u. And a is minus g, so it becomes minus g. And therefore the equation, the displacement time relationship for this first case summarizes to minus h is equal to ut1 minus half gt1 square, where the ball is projected vertically upwards. Moving on to the next case, which is the ball is thrown vertically downwards. Now the sign convention, along the initial direction of motion is positive, against the initial direction of motion is negative. So what is the initial direction of motion? It is dropped downwards. So all those values which are coming downwards would be taken as positive. Initial velocity is acting downwards, therefore positive. Direction of displacement, it is again acting downwards, therefore positive. Acceleration due to gravity at any point of this motion would try to bring this ball towards the ground, and therefore that is positive as well. Now if we put that into equation, S is positive, positive h, u is positive, positive u, acceleration is positive, positive g, and therefore the equation becomes h is equal to utb, this should be u t2 plus half g t2 square. Now taking up the third case, which is pretty similar, except for the fact that the ball is dropped here. Now when the ball is dropped, direction of initial velocity is downwards, displacement is downwards, direction of acceleration is downwards, or in other words, direction of displacement is along the direction of initial velocity, right? So direction of, let me just mark that for you. So direction of displacement is along the direction of initial velocity, and direction of acceleration is also along the direction of initial velocity, and therefore all these, all three of them are positive. And if all three of them are positive, the equation of motion, third equation of motion, transforms to S is equal to ut plus half at square transforms to h is equal to u is 0. Why? Because the ball is dropped. So this becomes h is equal to 0 plus half into gt square, or in other words, h is equal to half gt square. So now we have got three equations. The sign convention, along initial direction positive, against initial direction negative. Case 1, vertically upwards, minus h is equal to ut1 minus half gt1 square. Same sign convention. Now mind you, if you choose case 2 with a different sign convention than case 1, then there is a probability of error. Well, in fact, it would give you a wrong answer. Okay, so always make sure that you choose one sign convention for all the three cases in a given question. So case 2, plus h is equal to ut2 plus half gt2 square, and case 3, h is equal to half gt square. My bad. So how do we solve this? Well, see, the algebraic solution is not something we should be discussing in detail. Well, anyway, we just have a glance through it. So we got minus h is equal to ut1 minus half gt1 square. I will multiply this equation by minus 1. So what we get is plus h is equal to minus ut1 plus half gt1 square. And since both this equation, right, both these equations have RHS as LHS as plus h, the RHS can now individually be equated, and therefore minus ut1 plus half gt1 square should be equal to RHS of this equation, which is ut2 plus half gt2 square. To bring consistency in the equation, I'll bring ut2 to the LHS. I'll bring minus ut1 to the RHS and transpose half gt2 square. So this gives us half gt1 square minus half gt2 square is equal to ut2 plus ut1. So we got half g common in these two terms. U is common in these two terms, so that becomes half g the whole into t1 square minus t2 square is equal to u into t2 plus t1, right? A square minus b square is a plus b into a minus b. Therein t1 plus t2 plus t2 plus t1 is equal to, by t2 plus t1 is equal to 1. So what we get is half g into t1 minus t2 is equal to u, or u is equal to g t1 minus t2 by 2. From equation 3, h is equal to half gt square. So now we got two variables, u and h. And what do? We bring that back to case 1. And when you substitute this as in case 1, h is half gt square minus h is minus half gt square. We have just derived it now, half g t1 minus t2. So u becomes half g t1 minus t2. Is it negative or positive? Okay, that's positive. Into minus half g t1 square. Now, from this complete equation, right, 1 by 2 by 1 by 2 is 1, g by g is 1 by 2 g by is 1. So what we have is t square is equal, minus t square is equal to, opening up this brackets, t1 into t1 is t1 square, minus t2 into t1, minus t1 square. So t1 square minus t1 square is 0. So we are left with minus t square is equal to minus t2 t1, minus and minus becomes plus. So what we get is t square is equal to t2 t1, and therefore t is equal to root of t2 t1, which gives us the answer as, well, let me just confirm the answer as well. So the correct answer therefore becomes root of t1 into t2. So this is sign convention chosen method 1. Now we'll do the same question using coordinate axis. Okay, and when you do this, I would suggest you write down both these equations, both these methods once with me, and then compare on your own what is the difference, the mathematical difference between these three cases when you choose these separate sign conventions, methods of sign convention. All right. Okay, so maybe I'll just leave some space here to write down the final calculations. Right.